minus b times a plus b. Do you see that? The square root of x is a, 14 is b.
Yeah.
Okay, now this reduces always to a squared minus b squared. Now you can FOIL, but the thing is this, it'll be a lot faster if you remember different squares, especially if you end up doing it a lot, because it ends up being x minus 14 squared, like that. Or you can think of the square root of x squared like that. Maybe that's a little easier, which becomes x minus 196. And that's all in the numerator. Like everything I just showed you on the right is in the numerator. So it's the limit as x goes to 196, x minus 196, square root of x plus 14. And so notice that these cancel. Okay. Now the mistake here, and this is why your answer is not correct, is there's still a 1 in the numerator. You're always multiplying the numerator by 1.
Okay.
Okay. So from here, you always go back to, well, can I try the number? Can I try the number? Yeah, now you actually can, because you're not dividing by 0. So it's 1 over the square root of 196 plus 14. Square root of 196 is 14. So it becomes 1 over 28, like that.
Okay. Okay. I was doing the derivative.
Yeah,
Like,
no derivatives needed here. Oh,
okay.
well, actually, I mean, if you do take a derivative of square root of x, that would work. Because it's 1 over 2 square root of x, and then you put 196 in, and you get 1 over 2 square root of 196, which is 1 over 28.
Okay.
But you'd have to know which function to take derivative of.
Okay.
All right, so you want me to do these in order, like meaning next do 10, or go to,
It doesn't matter.
3? Okay. Or the order they came in, because it's always a little different. Like the next one here is 25.
Okay.
All right, I'll do 25 next. All right, find the horizontal and vertical asymptotes. So the horizontal asymptote, what you have is correct here, but it's not an equation. You want to write y equals
Oh,
0.
yeah. Okay.
And then same thing with the vertical. While what you have is correct, it's supposed to be x equals 6, like that.
Okay. Okay. Good to know.
Yeah, and that's that's the Pearson. It's like, which one is it? Now your graph is correct. Graph C is fine. Just you could graph it, or match them up.
Mhm.
Okay. Number 2 is the next one I see here.
Okay.
It's not answered. Is that okay for us to
Yeah.
go to?
Yeah. I didn't answer it.
Correct. All right, so find the slope of the curve at the point 2, 4 by the limiting process. So you've already taken calculus, so you don't have to do that. You have to be able to take a derivative of this. I mean, have you seen enough calculus? Because you said you've taken the class a couple times. Like, do you remember how to take a derivative of this?
Yeah.
Okay, so the derivative y prime is 2x minus 3.
Mm-hmm.
Okay, so and then to find the slope, you take this value of x, which is 2, and you put it into the equation there. So it's y prime equals 2 times 2 minus 3. 4 minus 3 is 1. There's your answer, like that.
So all I need to do is take the derivative.
Yes. Okay.
Okay.
So then for part B, you have to write the equation of the tangent line. Now the common one here is y equals mx plus b. Your slope comes from the derivative. The slope is the derivative.
Okay.
Like it's one of those things where it should be like in your face over and over again, slope, derivative, derivative, slope, so on and so on. But it's not, like, it's not made that clear, but it's y equals 1x plus b. And then you've got a point. You've got a point here, 2 comma negative 4. That's your x and that's your y.
Mm-hmm.
Excuse me, use that to solve for b. So negative 4 equals 1 times 2 plus b. Negative 4 equals 2 plus b. Subtract 2, b equals negative 6. That goes back in here. Now notice the box. This is all the Pearson stuff. This is the heartache of online classes. Is you have to remember that you're putting in just the right side. So it's 1x minus 6 or just x minus 6 because the y is already there on the
Mm-hmm.
left.
Okay.
Need to step away for 30 seconds. I'll be right back.
Okay.
All right. One of the benefits of working from home is there's always something going and it's like,
Yeah.
I gotta go, you know. Whereas when you're not working from home, you never know things are
Yeah.
happening. So so unfortunately the next few problems here, let me see if I can actually snip this in. There it is. All right, so part A, it says which of the following is the bicyclist's average speed? So average speed really means the same as average rate of change
Okay.
over the time interval 0 to 1. So what you do is you put a dot at 0 and a dot at 1, and you calculate the slope between those 2 points. Okay,
Mm-hmm.
so slope and it's most, and that's what average rate of change is. It's slope, which is the derivative. It's just rise over run.
Okay.
So you say, okay, I want up 8 and right 1. Up 8, right 1 is 8. Is that okay?
Yes.
So the other thing you should notice here is that this graph is going up into the right, which means all the slopes are going to be positive. So like in the next one here from 1 to 2.5, it's not going to be that one. It's not going to be that one. A and D are out because it's not positive. Now, you do the same thing. You put a point there at 1 and 2.5. And then you just do the same thing. It's rise over run. Maybe I'll switch colors here. You're going up 8. Sorry, not up 8. You're going up, yeah, you're going up 8, but right 1.5. So this time it's up 8, right 1.5. So I guess that is 5.3 for your answer there. And then the
Okay.
next one's the same thing. You're going from 2.5 to 3.5. So there's 3.5. So it's your rise over your run again, 4 over 1. That one right there.
Okay.
So average rate of change is the slope. It's rise over run, rise over run, rise over run.
Okay.
Do you feel like you could do that on your own if that came up again?
Yeah. Yeah.
Great, great. All right, so one of the nice things about the virtual format here is I can re-snip the questions and the graph here, and we can go on to B and do as much here as we can here. So let me snip this in, move this up. Which of the following is the bicyclist's instantaneous speed at 1/2? So at 1/2, there's 1/2 right there. You're supposed to draw what's called the tangent line.
Okay.
Instantaneous means tangent, whereas the previous ones were actually secants. And just to be clear here, you took a course at some point in geometry or trigonometry. If you think of a circle, a secant line goes through it twice, and a tangent line hits it once.
Okay.
Okay. So the rough tangent line here, the rough tangent line is something like that. Okay. And
Mm-hmm.
we're supposed to figure out the slope of it.
Oh,
Okay.
right.
And I mean, I didn't do a great job here, but you can see it's up some, it's right one. The only one that's even reasonable is this 8.
Okay.
Like it's more about kind of reasonableness when it's multiple choice.
And we know none of it's going to be negative. Okay.
Most likely not gonna be. Now at 2, there's 2. Let me actually switch colors here. There's 2. There's a horizontal tangent there. Do you see that?
Mm-hmm.
So that's 0. That's a slope equal to 0. So horizontal tangents have a slope of 0.
Okay.
And then And then the last one here at 3, let me switch colors here at 3. There's kind of 3 again. So, we're kind of looking at answers. It's not the negatives. So it's either 29 or 4. 4 look a little bit more reasonable. I mean, you can do the rise over run thing again, but you have to, you have to kind of, maybe do quick division
Mhm.
on it. Like you're going up, 12 over 2. So it's about 6. I mean, that's closer to 4. You're
Right,
not going to get it exactly like this unless you draw a perfect tangent.
okay.
And if I'm giving you too much information, say, Matthew, just, dial it back a
No,
little bit.
it's making sense. I haven't taken geometry since I was in high school, so it's been a really long time.
Yeah. All right. Which of the following gives you the maximum speed in miles per hour, and when does it occur? So you kind of want to look back at your previous answers here. Like you don't want to I mean, we never saw anything that was like as big as 41. It's
Mm-hmm.
probably the 16s. Okay. So where is it 60 miles per hour? Basically what we're doing is, and let me go back to the graph to explain this. We're looking at the graph and figuring out like, where is the tangent line the steepest? Like where is it kind of going up the most? So kind of like for me, it looks like it's going up the most right here at 1-ish. Like that's
Mm-hmm.
the steepest tangent line. That's
Yeah,
not as steep as this one over here. So I would say it occurs at 1 and it's 16 miles per hour like that.
okay. Okay.
Any questions on that before we move on?
No, I think I got it. Thank you.
Okay. Um, do the next one. We need the graph. So first one is the limit as x approaches a. Sorry, as x approaches 1. Okay. So to do a limit, when it says x approaches 1 or a number, what that really means is it's called a two-sided limit.
Okay.
You have to check the limit as x approaches 1 from the left, limit as x approaches 1 from the right. So, and when we say 1, we're referring to the x value.
Okay.
So you got to be like, okay, it's right there. There's x equal to 1 right there. Like you want to make sure that that's really clear. I need to undo that. Now from the left, literally means from the left.
Okay.
Okay, so what is the y value that approaches? What is the y value there that approaches?
1.
1. So this equals 1. And then the other one is from the right.
Mm-hmm.
From the right. So from the right is going this other direction. What is the y value there?
0.
0. Are these the same?
No.
No, so the limit does not exist.
Okay. So
It
they have
has
to
to
be the
approach
same.
the same value.
Okay. Okay.
All right, so part B. For this one, I'm going to just snip in the okay, so this is really when it says x approaches 3, it's really the limit as x approaches 3 from the left, limit as x approaches 3 from the right. Again,
Okay.
you got to go to wherever 3 is. There's 3. And you go from the left, from the right.
Mm-hmm.
What is the y value that it approaches from the left?
1.
1. What about from the right?
1.
Because this time it does exist. It's 1.
Okay.
You might think you've got it. The next part is a really important example for us to do. So let me grab
Okay.
that one here. All right, so 5. So we need to find the limit as x approaches 5 from the left, x approaches 5 from the right.
Okay.
Is that okay? So
Yeah.
from the left here, and this is where it's a little bit awkward. From the left, what does it approach? What's the y value? And notice there's a hole there. Still approaches that. So the analogy I use is like a mirage. Like so nothing is there, but you think there's something there. And what's the y value where it is?
I think it's 0.
Zero.
Yeah.
Now, how about from the right?
I think it's still 0.
Yes. So
Okay.
even this is important, even though it doesn't like there's nothing there, you're still approaching the same thing.
Okay.
Which I mean, it's kind of weird, it's maybe it's like, you're like, hey, friend, we're gonna go meet over at the wherever, and you both get there, and it's like, oh, the place isn't there anymore. And
Yeah.
I've had that happen in my life. Um, because the awkwardness is that the function is defined there. It's like, oh, you think it was there, but they just moved. They moved to another location. So does the
Mhm.
limit exist? Yes, the limit exists, even though the point, even though there's nothing there, the limit exists,
Okay.
which is awkward.
Yeah.
A better word, but because it is, but it does exist. So let's do the last grouping of these. This is a classic test question, by the way. I mean, this is, if you were in a classroom, you'd for sure get one of these on your test. I mean, this is you're guaranteed to get that. So now you're approaching 3.5. So 3.5 is, I guess, right there. So you just have to estimate the y value because it approaches the same thing. So I don't know, maybe 0.7, 0.8. I'm not sure.
Hmm.
There is some tolerance there, but couldn't say for sure.
Okay. So do they want an exact answer?
Yes, they want you to, I mean, I'm suggesting I'd probably put in 0.7
Okay.
if you're asking me.
Yeah, okay, that makes sense.
Okay, now on to number 5 here. All right, so fill in the blanks. As it really is important to have a graph of this. You said you're allowed to use your graphing calculator.
Yeah, I'm allowed to use a graphing calculator, just not desktop.
Okay. Are you comfortable finding the absolute value function? Graph it. It's under math, I believe. Let me know if you need help finding that. Because you really would want to graph something like this if you didn't remember the answer. So the idea is as x approaches 0, you really need to find the limit as x approaches 0 from the left, the limit as x approaches 0 from the right. And it's much easier to do with the graph. Okay. So the graph shows from the left that it approaches -1. And from the right, it approaches +1.
Hmm.
Okay. So that's what it says here. Left, I guess that's -1, +1. So the function, there's no single number L. I'll get, so I guess it's A, the answer. Because the idea is if you could write this in words, you would say the limit from the left does not equal the limit from the right, therefore the limit does not exist.
Okay.
And please give me some feedback if that, is terribly unclear. We can, you know,
I think it makes sense if you're looking at it from a graph's point of view. I think the
yes.
question is
And
really
you
good.
can graph that on your calculator without issue.
Um, you said it was in math.
Yeah, it was under, let me see if I can find it here. Math, I believe it's ABS under math num. Yeah, so let me grab a screenshot for you here. There it is, math num abs.
Okay.
Not like
And
the abs we have, but the
yeah,
absolute value. probably a math joke in there somewhere. Math jokes are the worst. They're just not funny. All right. Sorry, this is unrelated to this question. Sorry. Move it back up to, I guess I'll put it here. Okay, this is correct. Next one here, this is number 6. You always just try putting the number in. If it works, it works. Move on. All right, we'll go to number 7. Okay, find the limit as x approaches 19. So when you put 19 in, you end up getting 0 over 0, which is bad. You're not allowed to divide by 0. No division by 0.
Mhm.
That's really bad. That's like if you take a probability class and you get a probability of negative, that's really bad. So what are your options? Like one of your options is to factor, okay? So the bottom is difference of squares. It's actually 19 squared down here. It's
Mhm.
a squared minus b squared, which we talked about earlier, a minus b, a plus b, like that. So it ends up being that it's x minus 19 over x minus 19, x plus 19, like that. Now, what is in the numerator? What has to be in the numerator? It's not 0, it's
1.
1. Yeah, so this becomes 1 over x plus 19, and that 19 goes in for x. So it's 1 over 38.
Okay. Like I said, I forgot how to do it, so I looked it up and it told me to use the derivative. So I guess I'm doing it wrong.
Yeah, problem is you don't know what to take the derivative. You got to take the derivative of the whole thing,
It
eventually.
was telling me to use something called La Hospital's rule or something like that.
Yeah, L'Hopital's rule. Yeah, so it does work. So your derivative, though, would be 1 in the numerator and then 2x in the denominator. And then when you take the limit as x approaches 19, you get 1 over 30 again.
Then I just did my math wrong.
So you know, and full disclosure, I retook a couple of courses in college. You know, I had a weird period in my life where, you know, I needed to do that. And it was weird retaking the class because you already knew a bunch of stuff and you're like not supposed to use it.
Yeah.
Uh,
Uh-huh.
and it's hard. It's like, well, I already know that there's a better way. Well, unfortunately, you got to do it the way that they specify. So
That they want it. Yeah.
yeah. And I think they don't tell you that when you retake a class. They don't warn you like, yeah, you're actually gonna not like it because so it's better, you know, if you can hindsight, it's better if you could have just muddled through, or but you know, we
Yeah.
can't do anything about the list, so whatever. All right, so this one again, you could use L'Hopital's rule, but you're not supposed to know that yet. You're supposed to factor here. You're supposed to say, okay, in the top, -2 x plus 6. -2 out of both. Again, let me know if any questions on that. Bottom, you're going to factor an x squared. There's an x plus 6. Those cancel. That's good news. So you're now finding the limit as x approaches -6 of -2 over x squared, like that. And then again, this is where you just put the number in. So it's -2 over parentheses -6 squared, -2 over 36, 18.
Yeah, that's what I got. I just used the other rule. But I'll factor if they ask for the work, so they know.
They never ask you for work in this course, as far as I can tell you from all the,
Yeah, it's all multiple choice.
yeah.
Uh,
I feel like we already did 9. Can you verify that?
Yeah, we did 9.
Okay. All right, number 10. So here we go. So f of x plus g of x, you've got number 7 and a -3. Notice that's a -3 here. So the first one is 7 plus -3, which is 4. So you want to change that. Part B is really, it becomes 7 times g of x, 7 times -3, which is -21. So that's good. F of x times g of x, you multiply them together, 7 times -3, which is -21. That's good. And then f over g, 7 over -3. That is good there. Excellent. Good. Like that you're trying them. That's always a good thing. All right. You know, we got 20 minutes left. Just want to make sure we're going to get through everything.
Yeah, I think
I see only a couple more questions. Is that,
there's only
oh,
2 left, and then,
oh, good, good.
yeah,
Because obviously the last thing I want to do is have you get through this.
yeah.
So, yeah. All right, use the following functions, graph to answer the following questions. Okay, so the limit as x approaches 4 from the right,
Mhm.
you're going to use the one that says x less than 4. That means you're using this top one here. So you're
Okay,
putting 4, you're going to put 4 in for x. That's 5 minus 4, which is 1.
so the limit's 1.
Yes, yes. 5 minus 4. You're putting 4 in for x in that top equation.
Okay.
Okay, so from the left, I'm sorry. Whoa, 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 whoa. I just said a bunch of things wrong. Sorry. So this one from the left
Mm-hmm.
is x less than 4. I'm glad you questioned what I was saying, even if you weren't doing it intentionally, because I do make mistakes and I do sometimes not say things correctly, which is what happened here. So from the left is less than. From the right is this greater than. I don't know why that from the right is x greater than 4.
Okay.
So you're using the second one here. You're putting in 4 over 2 plus 2. 4 over 2 is 2. 2 plus 2 is 4. So this is 4.
Okay.
So here's something key, and I'm going to just type this, is that because it's something that you should really take away from this part of the course, is you can always determine a one-sided limit. So that means from the right, from the left. Meaning like B is not even a reasonable answer because you can always find it from the left, from the right.
Did I give you
I'm
the
sorry.
graph in the
I'm
picture?
sorry. I'm sorry. When I say B, I meant this B in here. So part B is the question B, or that's not what I'm referring to. So this one here, and do you have a question? I'm sorry.
Oh, did I give you the graph in the picture?
No,
There's a
but we
graph.
don't need it. We don't need it for now. So for this one, does the limit f of x exist as x approaches 4? Well, it's like this. Is the limit from the left the same as the limit from the right?
No.
No. So that is that one there.
Okay.
Part C. Part C is asking about the limit as x approaches 5 from the left, from the right. Now, if we go back to, let me grab a snip of that. The piecewise function that we're starting with. Piecewise function they're starting with. So because it's 5 is greater than 4, we're using this for both. We actually don't care about that one at all. So we put 5 in and we get the same result both times. 5 over 2 plus 2, 5 over 2 plus 2, which ends up being 4.5. Now simplify your answer. Maybe it wants 9 halves. I don't know if it'll take 4.5. You should just be very careful with that. The answer to part B looks like it's going to be A. Because it does exist and it's 4.5 or 9 halves, whichever it says.
Mm-hmm.
It's cut off on my screen.
It just says simplify your answer.
Okay. 12 is a kind of a really similar question. Is that where we're going? Is that okay to go to next?
Yeah.
Okay. All right. So graph 1 minus x squared for x not equal to 1. So 1 minus x squared, it's going to look something like this going down. They all do that, I think. Yeah. Now at -1, there's a hole there. And then
Okay.
at -1, it's saying, no, there's the hole, there's a hole, but it's a point there up at 2.
Okay. All right.
So whichever graph looks like that, kind of looks like B or D.
I think it's D.
I think it's D. Yeah, you got to really zoom in on them to tell. That's harder. Every time I zoom in, it doesn't work. So let's see. Let's see if I can just grab a snip of that, if it will zoom in or not. Yeah, it does. Good. Okay. So now we can do part B.
Okay.
Part B. All right. Limit f of x. X approaches -1 from the left. -1 from the left. So, there's -1. So from the left, the y value is 0.
Okay.
Okay. Like, it's good to kind of trace the curve or draw some arrows. I know you don't have the digital ink, but that is the right approach here for that.
All right.
Part
Yeah.
well, still part B, the limit as x approaches 1 from the right. So from the right means coming the other direction, looping down, that's still 0.
Okay.
We did a problem like this earlier where they approach the same thing. That's great.
Yeah.
It's always super nice. So then part C is, well, does the limit exist? So you have to ask yourself, does it approach the same value from the left and the right?
Yeah.
If it does, it ends up being 0.
Okay.
Right. Just kind of curious, what did you do to try to answer this one?
This one was the one I was most confused on because I graphed it and I didn't know if I was supposed to be looking at one line or the other. And then when I plugged it in, it gave me like this crazy decimal. So I didn't know what to do.
Okay. Um, it's minus 0.2,
Mhm.
which is not, it's undefined at -2.
Okay.
All right. But you have to be able to take the square root of this. So, for lack of a better, I mean, I don't really have a better plan here, but like it's -1/5 is what it is. So we're gonna put -1/5 plus 11 over -1/5 plus 2, and then take the square root of that. Like, you always try the number. Now, you said graph it, but when you graph this, and just to be clear, the way you would graph this is you would have to go square root parentheses x plus 11, sorry, the parentheses for the root, slash x plus 2 in parentheses, like that. It would need to be put in y1, much like this.
Okay. Then I graphed it wrong.
Which is no big deal, right? I mean, whatever, make a mistake, no big deal. Now, it does exist. It's just not a nice number. So it's essentially, we've got to just reduce this fraction. this stuff here. So 11 is really 55 over 5. So it's minus 1/5 plus 55 over 5, which is 54 over 5. And then this is 10 over 5 minus 1/5 plus 10 over 5, which is 9 over 5. And then you're dividing. So whenever the bottoms are the same, you can cancel the bottoms. You end up getting 54 over 9, which is 6.
Yes.
So it ends up being the square root of 6.
And they'll let you put it in like that.
So the thing to do is to like in your calculator is to go and do the minus 1/5 plus 11 slash minus 1/5 plus 2, or the minus 0.2, and then do the math, enter. Because what that does is that gives you the fraction. That's the 2 frac for fraction. Have you seen that before?
Yes.
Okay, and that is very helpful. Now don't do the square root, because the square root messes things up. You get that number, and then if you did this right here, you'd get 6, and then you put the square root with it in the answer, because we don't know the square root of 6. It's a irrational number. It's kind of unkind, when you call someone irrational, it's like they're crazy.
Yeah.
All right, so does that get through everything you wanted to get through today?
Yeah.
What I
I
would do is go through and just check that you've entered all the answers correctly, or if you have any other questions before we got 10 minutes here if we need it, but
Let me make sure I answered everything. 'Cause sometimes it says I didn't answer something. I know next week I have 2 quizzes due, and I think following the weeks after that, it's 2 quizzes every week. But
okay.
there's 2 due next Saturday, not tomorrow, but the Saturday after. And then my midterm is the week after that. But there's like this 2 things you have to do for Rio Salado to take the midterm. So you have to I'm sure you know, but you have to do the big exam thing to take it. And I have to drive to Phoenix to take it.
It's hot there. It's hot
Yeah,
everywhere right now.
I'm from Tucson, so I have to drive to Phoenix every time I go.
Yes.
I try to take it at the U of A, but they charge $40 an hour. It's really
Ooh,
expensive. So to take a test. So and it's like a
yeah,
3.
and they're a not-for-profit university, except they are.
Yeah.
Oh boy.
I think I answered everything.
Okay. You want to we can close out here? Or do you want to? I mean, we've got a little time left if you want, but
We can. I don't think I have anything else for today. I think the
Well-
next time we could schedule, if you have availability.